Okay, so finally we are here to know about how to implement the binary search. Okay, so I'm just writing renaming the code over here. Okay, and I'll name this to binary search iterative one. Okay, so this is the iterative one. Let me first code it for you, and then we'll get into the understanding of how exactly it works. Okay, so first of all, what do I need to do is that after def, we'll write down the name of the function, that is binary underscore search, and then we have the list which we want to be searched. Okay, let me name it list1, and n will be exactly the same like the previous one also. And as I told you about low is equal to 0, high is equal to length of the list1. And what to do with that? Definitely -1, because we are working with indexing, right? And then you have mid is equal to 0. Okay, next what you need to do is that, since I told you it's iterative method, we will be using while over here. Okay, so while low is lesser than equal to high, then mid is equal to high plus low. Okay, and what I'll do, I'll write okay, it will be just mid is equal to, not double equal to, since I am yeah, all right, double divided, because we do not want the decimal value right now. That is why I'm using division sign twice. So this, what will this do? It will check, it will get the result in the integer value. Okay, and then now the next thing which we need to do is that we need to check if n is present at mid or not. So the first thing which we will do over here is that get back over here, and if list1 mid is less than n, okay, then low is equal to mid plus 1. Okay, then there is elif, because there will be one more condition, elif. Now list1, what do we need to check? Again, if it is greater than mid. Okay, so if it is greater than mid, this thing is greater than n, then definitely high is what we need to change. High is equal to mid minus 1. Okay, else only one thing remains. If these two are not the case, then it should be one and only thing which is left, that is mid. Return mid. And if these are not the case, then what you could do is return, I guess these all should be inside while. So I'll put this, yeah. And ret return -1, that means it's not present, simply as we have done it before. So let's just take You should remember that we need to sort the list if it is not sorted. So I'll take a list 1, which is already sorted. So let me write down 1, 2, comma 3, 4, 5. Cool. So the next thing which I need to do is that n, which number do we need to search for? Let's search for 8. Okay. And if we are searching for 8, we need to definitely store it somewhere, right? So just like the previous one, result is equal to binary search, and then you definitely need to pass, that is list 1, and the second thing, that is n. That's what you need to pass. Okay, so now okay, there are 2 brackets, we just need 1 brackets, we don't need 2 brackets. And as we have already stored the result over here, so if result is not equal to, there we did equal to, right now let's do something, let's do it, work with not equal to. If it is not equal to -1, that means this guy is present. This is the formatter which I have installed, that's the reason it shows you not equal to in this way. Okay, so I'll just simply write down print element is present, element is present at index. What is the index it is present at? It is present at str. We need to convert it into a string because it's integer and we are adding them, we are putting them all together, that's the reason. So it's result. Okay, now if it is not the case, that means else. What I'll do, else element print element is not present. Cool. So now let's try and run it. I was trying to search 8. So yeah, element is present at index 7. Okay, and now let's try doing one more thing over here, that if the element is not present, let me make it 80. So see, element is not present. So what exactly are we doing over here? We have created a function over here, right? Yes, we have created a function over here which is known as binary search. Okay, this takes up 2 arguments. One is the list, another one is n. N is the number of elements that is present over here. Now we have declared 2 variables to store the highest value in the list and the lowest value in the list with the help of high and low, and mid is also equal to 0. Next, what we have done, we have taken a while loop with the condition that if the lowest is equal to the if the lowest is equal and smaller than the highest, then what to do, and while loop will iterate to the number that has not found yet. After that, in the while loop, we find mid value and compare the index value to the number we are searching for. If the value of the mid index is smaller than n, we increase the mid value by 1 and assign it to the search, and it moves to the left side, or else it will decrease to the right side. Okay, the search moves to the right side, it will be decreased and the search will move to the right side. And if the n is equal to the mid value, then it will just return the mid value, and this will happen till you find the number. Okay, so this is how we work with the iterative one. Okay, this is how we work with the iterative one. Now let's talk about the recursive binary search. Okay, in recursive binary search, there are some visible difference over here. So what I'll do, I'll teach you that in the next video. Till then, practice this one, and if you have any questions, you can definitely ask me. Okay, so yeah, that's it for this video. Meet you next time.